Now, reaction with metal oxide. So, metal oxide plus the acid. Plus the acid, you will get salt plus water. Okay, example, copper oxide plus HCl. We get copper chloride plus the water. Okay. Copper oxide plus HCl, you will get copper chloride plus the water. So this is a salt plus the water. So what we use common salt, no? What is that? NaCl. NaCl. Sodium chloride. That is a salt. And that is a neutral salt. That is why we use it. Neutral components, it is safe to use. It should not be too acidic or too basic in nature. Mild acid, mild base, or a neutral compounds we use to consume. So sodium chloride, which is a common salt, what we use, it is neutral in nature. Okay. Okay, so bases are the compounds which are bitter in taste. Baking soda is there, right? That is also a base. Just put that in the mouth and see. It will be bitter in taste. Okay, so bases are the compounds which are bitter in taste. They produce OH minus ions in the water. In the water. Okay. They are soapy to touch. Soapy to touch. It turns red litmus to blue. It turns red litmus to blue litmus. Blue litmus. Okay. So, what is the characteristics what we have with the base? How you can say anything is a base? When it is dissolved in the water, it produces OH minus ions, or it mainly contains OH minus ions. So, then we say that it is a base. For example, you consider, we will write NaOH. That is a base. Calcium hydroxide, CaOH, twice. This is a base. KOH is a base. Okay. It contains OH group. That is why it is considered as a base. Okay. OH is what? Hydroxide group. OH, wherever it comes, it is hydroxide. Okay. Hydroxide group. And its valency is 1. Its valency is 1. So NaOH, how it is formed? Sodium valency 1, OH group valency 1. So cross multiply, you will get NaOH. Okay. Calcium hydroxide, calcium valency 2, OH group valency 1. Cross multiply, 1 calcium reacts with 2 OH group. That is why it is CaOH twice. Okay. So, bases are the compounds which are bitter in taste. They produce OH minus ions in the water, and they are soapy to touch. Okay. See, soaps, what we use, no, that is also bases. They are soapy to touch. And also, it turns red litmus to blue litmus. Since it contains OH minus ions, we call it as a base. Okay. So, OH is what? Hydroxide group. Its valency is 1. So NaOH, calcium hydroxide, KOH, all these are the bases. Now we'll try to study chemical properties of bases. And what is pH of bases? More than 7 is the pH of the base. And if you consider 8 and 10, two bases, one compound A with pH value 8 and compound B with pH value 10, which is more basic in nature? 10. The compound which is having pH 10, it is more basic in nature. Okay. And now we will study about chemical properties of bases. Chemical properties of bases. Okay. Just close the door. First one, a reaction with metals. Reaction with metals. That is how bases react with metals. Okay. You will get metal plus a base. Okay, metal with the base. You will get salt plus hydrogen gas. That's the hydrogen gas. Okay. For example, zinc plus the base NaOH, sodium hydroxide. Okay. So you will get a salt plus the hydrogen gas. Okay. It is right now Na2ZnO2. Na2ZnO2. It is sodium zincate. Sodium zincate. Okay. Plus the hydrogen gas. Zinc plus NaOH, a metal with a base, you will get a salt plus hydrogen gas. So you will get sodium zincate plus the hydrogen gas. Next one. Reaction with non-metallic oxide. So non-metallic oxides are acidic or basic? Acid. Non-metallic or acidic in nature. So when acid reacts with a base, what happens? What you will get? Salt plus water. So here also we'll get the same thing. Okay. Right. Base plus non-metallic oxide. Base plus non-metallic oxide. You will get salt plus water. Okay. So base, if I consider, it is calcium hydroxide. It is a base. Okay. Plus non-metallic oxide, carbon dioxide. You will get calcium carbonate plus the water. So calcium hydroxide plus carbon dioxide, you will get calcium carbonate plus the water. Okay. Next, acid and bases in water solution. Acid and bases in water solution. Okay. That is, if you mix an acid in the water, so what happens? If you combine the base in the water, what happens? That we try to see here. Okay. So HCl, for example, HCl plus the water. So what you will get? H3O plus Cl minus. Now how do you get this? First HCl will split into H plus ions plus Cl minus ions. Okay. So that combines with the water. They form H3O plus ions. Okay. So and this Cl minus will be there. So if you combine these two, you will get the First equation. Okay. So hydrochloric acid, it dissociates into H plus and Cl minus ions. This H plus ions combines with the water to form H3O plus ions. So they are called as hydronium ions. Okay, hydronium ions. These are called as hydronium ions. So you can actually, uh, if you want to test with the litmus paper or any indicator, when you combine with the water, then only you will be able to know. That is, if you take dry HCl gas, if you pass through litmus paper, it will not give the litmus paper test. That is, it will not turn to from blue to red. Why means that H plus ions, it will not split and it will not produce H plus ions. So it will not give the litmus paper test. If you dissolve HCl gas in the water, you will get HCl. It will split into H plus and Cl minus. That if it combines with the water, it will form H3O plus hydronium ions. H plus ions or hydronium ions, any ions, that measure only will give you the pH value. Okay, if that also they will ask, if dry HCl gas is there or the diagram they will give, that is passed through the litmus paper. So what is the answer we will get? So here blue litmus paper will not turn into red because it is dry HCl gas. It does not contain water. Okay. But if it is combined with the water, then it produces H plus ions, then only it will give the litmus paper. Understood? No? Like that. So when you combine acid with the water, what happens? It first HCl will split into H plus and Cl minus. This H plus ions combines with the water, it forms hydronium ions. Plus the Cl minus ions could be there. Okay. That's what it happens. And when you consider a base, for example, NaOH. So what happens to NaOH? In the water, it splits into Na plus and OH minus ions. In the water, it splits into Na plus and OH minus ions. So that measure of this OH minus ions will give you the pH value. Okay. If it is more, the pH value will be more. Like that. Okay. So this is about bases. So to indicate whether it's a base or not, it should be dissolved in the water. Then it will give the litmus test. Okay. Now, how to add an acid to the base? Can we just mix acid directly to the base? No, you can't do because it is a highly exothermic reaction. Acid combining with the water, it is a highly exothermic reaction. So it is, and it is very fast reaction there. So what happens? That it's start bumping out. That acid will start bumping out, comes out because of that heat. So whenever you want to add acid to the water, you have to add acid drop by drop to the water. These questions also they were asked in the exam. Okay, how we will combine acid and water means you should not directly add acid into the water. So you should add water into the acid. Sorry. You have to add, if they think you have 1 tumbler of water. So if you want to add acid into it, add it drop by drop. Okay. For the water, you have to add the acid drop by drop. You have to add. Why? The reason it is highly exothermic reaction. It produces enormous amount of heat. So that if you add drop by drop, it is better. So it doesn't pump out. Okay, that's how you will add water, or you will mix acid and the water. Okay, this is about that. Then what else is there? Write down about that. Effect of dilution of an effect of dilution on an acid. mixing of an acid or base with water is called dilution. Is called dilution. Write a note. Acid is added drop by drop into the water as it is highly exothermic in nature. As it is highly exothermic in nature. Okay. Should not add water directly into the acid so that the whole acid starts reacting. No? That's why for the water you should add drop by drop acid since it is a highly exothermic reaction. Okay. And even in the lab when you are doing, you should take care about that. You are adding an acid and drop by drop. Okay. Even weak acids. Even weak acids. Yeah. Weak acids also can't add. It will produce less heat when compared to this, but whenever it's an acid, it's safe to add dropping. Okay. We studied about that. Next, about the pH value, on that day also we studied. So pH of the organisms will be like very near to the neutral. Okay. It will be very near to the neutral. If the pH changes drastically, then what happens? The organism will die. Okay. For example, in the soil, we have many microorganisms will be there. If we put more pesticides and all, it becomes acidic in nature. Then the microorganisms may die, and even the plants will not grow well. So what they do, they actually test the pH of the soil, and if the variation is more, so they add a base for that, maybe like potash or something, so the pH will be changed so that they can change the pH near to the neutral. Okay. So, and acid rains, you would have heard about the acid rains, right? What is acid rains? No, acid rains. Huh. Huh. What happens actually with the water? So, if the rainwater, see, when it is coming in from the clouds, it will be neutral in nature. Okay, when it start coming into the atmosphere, what happens? It starts combining with the salts in the air. Correct. Salts will in the air. So, if the pollution is more, then the rainwater can become acidic. The rainwater can become acidic. If the rainwater pH value is less than 5.6, then it is called as an acid rain. Okay, then it is called as an acid rain. So, what happens with the acid rain? Yeah, I told no, pH should not vary much. So, the trees will not grow well there because it becomes an acid, right? So maybe the leaves start like in the leaves, wherever it falls, it may become a hole there, or the plant. Huh? Yeah, harmful to the humans also. Okay, you can't drink it directly, that water. By just a filtration, you can't drink it, right? And the plants will not grow well. Microorganisms may die. All this can happen with the acid rain. When we consider it's an acid rain, when the pH value is less than 5.6. When it is coming from the clouds, that it will not be 5.6. Okay, the water is neutral in nature. But when it comes through the atmosphere, what happens? For example, atmosphere has sulfur dioxide, sulfur trioxide more, carbon dioxide more, carbon monoxide more. I told they are non-metallic oxides. So non-metallic oxides, when they combine with the water, what they form acid. For example, we consider sulfur trioxide. So 3 is sulfur trioxide. They combine with the water, they form sulfuric acid, H2SO4. Okay, carbon dioxide with the water, it forms carbonic acid, like that. If it is more, then what happens? If it combines with the water, the rainwater becomes acidic in nature. So then pH value, if it is more, then pH may reduce to 5.6 or less than that. Then that water, we call it as acid rain. That we call it as an acid rain. Okay, which is harmful for the nature. This is about the acid. And in the digestive system, we know HCl is produced. That combines with the food, it makes the food acidic, and because of that, germs will die, and pepsin will act better in that medium. Okay. Then actually, it becomes alkaline by the bile juice actually. Then in the food, what happens? First, it becomes acidic. When in the small intestine, when it combines with the bile juice, actually it becomes alkaline in nature. Okay. So that's how it happens. But and also when it mixes with the food, it acidic value will reduce naturally. When it combines, it will reduce. And that HCl produced should not affect the stomach. That's why mucus is produced. Okay. So this is about the digestive system. But still, if HCl produced is more, then what happens? We have the acidic problem, gastric problem. All this will be there. So what we do? We use the gelusil or something, right? What is that? Gelusil. Yeah. What is that? Yeah, they are antacids. That is, they contain a base. Okay, and you would have heard of milk of magnesia. Rohit, what is milk of magnesia? What is the what does it contain? Correct, magnesium. Lakshit, what does it contain? Kiara. It contains magnesium hydroxide. It's a mild base. Magnesium hydroxide is a mild base. So we consume base to neutralize. Okay, you see, go on, see once. Gelusil or any liquid will be there, right? It is called, inside somewhere they would have written it is milk of magnesium. Milk of magnesium means it contains magnesium hydroxide, okay, which is a base. So it is an anti-acid, so which will neutralize the acid in our body. Okay. HCl plus magnesium hydroxide. If someone takes that, okay, it is milk of magnesium, that is magnesium hydroxide. Magnesium hydroxide is what? It's a base. HCl is an acid. Acid plus base neutralize. Bile juice. Yeah. No, not like that. After pepsin acts on food, it is passed through the small intestine, right? Okay, that bile juice will make that alkaline. Okay. So, tooth decay also we studied now. So, if in the mouth the pH value reduces or it becomes 5.5, then tooth decay will be more. Okay, tooth decay will be more. How it can become acid can increase? One is through acidity if it is more. The second one is the food remaining in the teeth, because of that bacteria will be produced. So that bacteria, when acts on the food, what happens? It will release acid. Okay, so it releases the acid. So because of the pH value reduces. So it may cause the tooth. Okay, that is the one thing. Yeah, and pH in plants should be also neutral in nature. So pesticides, if you use fertilizers, if you use more, actually pH of the soil reduces. So then the plants will not grow well. So what they do, they will test the pH value of the soil and they will add something to make it near to the nutrient. Okay, and for the plants also, like that range also maybe little bit variation will be there. So for the cotton to grow, they will check all this soil test and all they will do. No? pH test is also one thing. And they will also check nutrients and everything. Nowadays, what they tell is don't put all the nutrients there. So what is the deficient? So they will put that. So that the cost also will reduce and also only the required one you can put. Okay. So in the soil testing also they do the pH for that so that they can neutralize and plants can grow well. That is why actually they say pesticides you should not use more. And even in the water, pesticides, if you use what happens more, some quantity will be absorbed by the plant. The rest either will be in the soil or in the water. How when the rain comes, what happens? With the water, it goes pesticides. It reaches the water. Or it reaches the soil or the water. So directly or indirectly, it reaches our body. So it has to be used less pesticides. Okay. Okay, tomorrow we'll continue with the salts. Salts actually important portion. Tomorrow we will do that is chloroalkyl process. All these it is important. Many times they ask. Okay, tomorrow. So after this we will have one test. After completing, we will have the test. Okay. Okay.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.